unbalanced, balanced, unbalanced, balanced, unbalanced, balanced.
There are a lot of data structures out there that can be used to store information which have a high efficiency. We care about high efficiency. How do we get a high efficiency in using the tree data structure? By balancing the tree. A balanced tree is a tree that has a balance factor of -1, 0, or 1. A balance factor is the difference between the height of the left subtree and the height of the right subtree. The height is the maximum level of any node on the tree. The height of the whole tree is 3. The height of the left subtree is 0, while the height of the right subtree is -2. So using our balance factor equation, the balance factor of the tree would be balance factor equals 0 minus -2, which is +2.
Now we have to balance. As you see, the height of the left subtree is 0 and the height of the right subtree is -1, and that gives us the balance factor of 1. But how did we get to this balanced tree? We performed a rotation. We have 4 types of rotations: a left rotation, a right rotation, a left-right rotation, and a right-left rotation. When we have more nodes on the left, we perform a right rotation. When we have more nodes on the right, we perform a left rotation. In this tree right here, we can see that we need to do a left rotation because right now the tree is right heavy because there are more nodes on the right of the tree. However, in order to perform a left rotation on the tree, we would first need to perform a right rotation on the subtree of this tree. Now that the subtree of our tree is balanced, we have to perform a left rotation in order for the whole tree to be balanced. On this other example, we see how we have a tree that is left-heavy because there are more nodes on the left of the tree. In order to create a right rotation on this tree, we will need first to perform a left rotation on the subtree of the tree. After we perform the left rotation, then we continue by doing the right rotation. So why do we even care to balance a tree? Well, once the tree is balanced, we can access the cookies more easily because the height of the tree is smaller. We can see how Caleb wants to eat the white cookie, but if the tree is unbalanced, then he will have to go through all the cookies in order to get the white one, and by the time that he gets there, he's already full and cannot eat anymore. Poor Caleb! But once the tree is balanced, Caleb doesn't have to eat as many cookies anymore. He can only eat 2 to get to his favorite cookie. And now Caleb is happy!
Perfectly balanced, as all things should be.